Dear students, in this section we will learn about refraction. Refraction of light is responsible for producing beautiful rainbows and it is necessary for your eyes to work. So let us learn about refraction of light. We know light travels through vacuum at the speed that is equal to 3 into 10 to the 8 meter per second. It can also travel through many materials such as air, water, glass, etc. Then what happens? The atoms of these materials absorb, re-emit and scatter the light. Therefore, light travels through these materials at the speed that is less than the speed of the light in vacuum. The actual speed depending on the nature of the material. In general, we will see that the change in the speed as light travels from one material to another material, that change the direction of the light. That is, it is certain deviation of the light from incident direction. The change in the direction is called the refraction. To describe the extent which the speed of the light in material medium differ from the speed of the light in the vacuum, we use one parameter, that is the called index of the refraction or refractive index. So let us learn about refractive index or index of refraction of material. The index of the refraction or refractive index of the material medium is the ratio of the light speed in the vacuum to the light speed in the material. And we denote this property by a symbol mu or n. So we can write here that is equal to c divided by v. And here c is the velocity of the light in the vacuum and v is the velocity of the light in the material medium. This mu gives idea about the speed of the light in the material medium. Greater the value of the mu, lesser the speed of the light in the material medium. Now let us observe what happens when light strikes the boundary dividing the two transparent materials such as air and water. So let us make one situation here. You can observe this boundary, that is called the interface. It is dividing two medium, that is medium 1 and medium 2. This is the interface, incident ray, reflected ray and refracted ray. Okay. You can observe here, this reflected ray is obeying the law of reflection. That is the angle of incident is equal to angle of reflection. It is to be noted, always calculate the incident angle and reflection angle with respect to the normal direction. That is theta 1 and theta 2. Both will be equal in case of the reflected ray. And if this incident ray coming along the normal, suppose it is coming along the normal, this type of the situation is called the normal incident. And in case of the normal incident, there is no deviation of the ray path of the refracted ray. But if incident ray is coming other than normal incident, the refracted path will be always deviated. That is, deviation of the path of the refracted ray with respect to the initial direction. This situation is called the refraction. Correct? Now let us talk about the refracted ray. Refracted ray behave in one of the two ways. We will discuss here what are the two situations. One situation is when light travel from medium where refractive index is smaller than the medium of larger refractive index. Smaller refractive index medium is called the rarer medium and larger refractive index medium is called a denser medium. That means when light is traveling from rarer medium to denser media, light, that is refracted ray, bend toward the normal. Let us make the diagram of this situation. You can observe this is air, this is water, rarer medium, denser medium. This is the incident ray and you can observe the deviation of the refracted ray. That refracted ray is bent toward the normal. So when light traveling from rarer medium to a denser medium, the light will bend toward the normal. If we call refractive index of air is N1, refractive index of water is N2, and in this case N2 is greater than N1, and as we discussed, we always measure the angle of the incident ray, reflected ray and refracted ray with respect to the normal. So we can say measurement of the angle like this. This is angle theta 1, that's the incident ray make with the normal. This angle is theta 2, that is the refracted ray make with the normal. You can observe clearly that is theta 2 is less than theta 1. Now this is the conclusion, refracted ray is bent toward the normal. Now let us discuss situation 2. In second situation, what we will do? We will incident light ray from denser medium and it will travel toward the rarer medium. And it is observed, when light ray travel from medium where the refractive index is larger into the medium where the refractive index is smaller. Larger refractive index called the denser medium and smaller refractive index called the rarer medium. And in this situation, light is traveling from denser medium to rarer medium. You can observe here light is traveling from water to air. And in this case, you can observe the angle made by incident ray with the normal is theta 1. And here the angle made by a ray, that is the refracted ray with the normal is theta 2. And theta 2 is greater than theta 1. That means the light ray after refraction move away from the normal. These are the two very important observations about the refraction. Now you can observe these two possibilities about the incident ray and refracted ray. And one thing to be noted, the incident ray and refracted ray always obey the principle of reversibility. What is the principle of reversibility? Suppose light is traveling from this point to this point. You can observe the path of the light is along the path of the tip of my pen. And in principle of reversibility, I can say if light is traveling from this point, so light will travel the same path as it travel from top to bottom. And if it start from bottom, it will reach to the top point along the same path. That is called the principle of reversibility. You can verify principle of reversibility here. You can observe light is reaching in case 1 at this point and reaching to air at this point. And here light ray is traveling from water from this point and reaching to this point. That is, path is reversed. And one more thing to be observed here. You can observe the incident ray, normal, reflected ray and refracted ray all lie in the same plane. Okay. And one more thing you can observe here, that the both incident ray and refracted ray obey here the principle of reversibility. You can observe here the light ray is traveling here from rarer media and reaching to this point situated in the denser media. In principle of reversibility, if we reverse the path of the light, you can say if we change the situation, that is if we start from the point situated in water and finally ray will reach to the point situated in air. According to the principle of reversibility, the path traced by the light ray will be same. You can verify here in case 1, this is the path, you can follow this path, and you can observe here in case 2, this is the path of the light ray, this. You can observe the path of the light ray is same. That means the direction of the ray in case 1 can be reversed to give the situation depicted in case 2. Okay. And one more thing to be noted here, that the index of the refraction, that the refractive index of air labeled N1 in case 1, whereas in case 2 it is written as N2, because we label all the variable associated with the incident ray with the subscript 1 and all variable associated with the refracted ray with the subscript 2. We will follow this notation in throughout the optics section. Okay. And the angle of refraction theta 2 depends on the angle of incident, that is theta 1, and also on the index of the refraction, that is N2 as well as N1 of the two media. The relation between two quantities is known as the Snell law of refraction. So let us come to learn Snell law of refraction. There are two laws about the refraction. So let us learn law number 1. In law number 1, the incident ray normal to the interface at the point of incident and refracted ray all lies in the same plane. We can observe this situation through one diagram. You can observe this incident ray normal to the interface at the point of incident, and this refracted ray all lying the same plane. You can observe here one more thing. We have used the subscript 1 for the incident media, that is mu1 and theta 1, and we use the subscript 2, that is mu2 and theta 2 for the media 2. Okay, this is law 1, and according to law 2, that for any two media, the ratio of the sine of angle of incident to the sine of angle of refraction is constant. The ratio of sine theta 1, here angle of incident is theta 1, and sine of angle of refraction, that is sine theta 2, is constant for these two media. So here we can write sine theta 1 divided by sine theta 2 equal to constant, and this constant is equal to 1 mu 2, and here 1 mu 2 is the refractive index of medium 2 with respect to medium 1 when light ray is travel from medium 1 to medium 2, and it is equal to mu 2 divided by mu 1. Write this equation in the next page, and if we cross multiply this, so this equation will become mu 1 sine theta 1 equal to mu 2 sine theta 2, and it is equal to constant. Now we can say the product of refractive index and sine of angle made by the ray with the normal at the incident is constant, right? So now we can write mu multiplied by sine theta equal to constant. Okay.